Problem 12. The figure below shows a large white circle, which is this large one right here, with a number of smaller white circles and shaded ones inside. So these are the smaller shaded ones. We're trying to find the fraction of the interior of the large white circle that is shaded. So basically first out, list the following formula that you need to solve the question. Well, that will be the area of the shaded, right, divided by the area of the large circle. So let's solve for this term right here. What is that? Well, the area of a circle is pi r squared. So in this case, the radius of, or the area of this big white circle will be this radius squared times pi. So this is equal to pi times 3 squared, which is just 9. With this, let's solve for the shaded regions right here. Well, do we even need to solve for the shaded regions? Because let's do complementary counting, which is let's solve for all the white area within this shape, and then we can solve for basically the summation of this area plus this area plus this area plus this area and this area. What I mean by this, so first of all, what are the white areas within this large circle? So if I have, this rough resketch of the thing, this right here is shaded, right? And then that's shaded, that's shaded, that's shaded. If I can solve for the area of the non-shaded region, which is the white region right here, and then subtract that from the area of the entire circle, what I'm basically left with, I'm just left with the area of this, and this shaded region combined, which is exactly what I want, which is right here. So let's do that. So starting off, what is the area of this white circle, or that's 9? What is this circle radius area right here? Well, that's just pi r squared. The r is 1. Oh, and by the way, I'm assuming that every single one of these side lengths are 1. Granted, you could say that this is 10 or 100, but when you scale everything down, you can always scale it down to a side length of 1. And that, for me, is the easiest to work with. So I'm just going to say that's 1. So with this, that's why I said that this radius is 9, because with this definition of one space being 1 unit long. Back to the question, what is the area of this white circle? Well, that white circle is just pi times 1 squared. But we have 2 of them. So times 2 will give you the area of this and this combined. So that is equal to 2 pi. Now, what is the area of, this outer white area? Well, that outer white area is simply the area of the large circle, which is 9 pi, minus the area of 3 of these circles, which is just 3 times pi times half squared, and then subtract that by the area of this large circle right here, which is just pi times 2 squared, which is just 4. So that's equal to 5 pi minus 3 over 4 pi, which is the same thing as 4. 20 minus 3 is 17, so 17 over 4 pi. So this right here is the area of this outer white region. So the summation of 17 over 4 pi plus 2 pi would give you the total area of the white region within the large circle, which is 4, and then 8 plus that is 25 pi. So all we have to do now is just do 9 pi, right, minus 25 over 4 pi, and we get our answer. So the pi and pi, everything gets eliminated. So this becomes, in the numerator we have, I'll write it here, 36 minus 25, and that would give you 11, right? So 11 over 4 times 1 over 9, which is 11 over 36, bringing you to answer choice B.